Okay, so my demonstration was a little bit clumsy. I was spilling a little bit there, but just to clarify, in case it was kind of hard to see how many of each object it took to fill another, let's just go over these purple question marks. So the first one that I did was I filled up 3 cones in order to fill up the cylinder. So this would be times 3, where you're going from the cone to the cylinder. Oh, and before I get too far, the thing I was showing right at the very beginning was that all of the shapes, the objects I have, they all have the same height and they all have the same base width, basically. The diameter, because we're talking about circles, for all of the shapes are exactly the same. And the heights from the bottom to the top of each shape are exactly the same. So that's why these relationships work and help us understand where the formula comes from a little bit. Okay, so anyways, first one, the cone to the cylinder was 3 times, 3 cones to fill up the cylinder. So that means going the other way, 1/3 of a cylinder would occupy the volume of a cone with the same base and height. So you could also take the volume of a cylinder and you could multiply it by 1/3, or you could divide by 3. Okay, in the next example, we were going between the cone and the sphere. And so the first thing that we did is we showed that it took 2 cones to fill up 1 sphere. So we could turn that 2 times 2. Then going the other way, that means that a sphere would fill up exactly 1/2 of a cone with the same diameter and the same height. So this could be also times 1/2. And again, like the other one, where you could also, instead of multiplying by 1/3, you could divide by 3. In this case, instead of multiplying by 1/2, you could also just divide the volume of a sphere by 2, and you'd have the volume of a cone with the same diameter and the same height. The next example was going between a sphere and a cylinder. So this time we were going from, or sorry, we were going from a cylinder to a sphere and a cone. So on that one, it was just kind of a little side example. If you fill up one cylinder, that cylinder will fill up the volume of 1 cone and 1 sphere. So what that means is the sphere is 2/3 the volume of a cylinder. So if you were to take the volume of a cylinder and multiply it by 2/3, you would have the volume of a sphere with the same diameter and height. Do it the other way, if you took the sphere and filled up the cylinder, you would need 1.5 or 3/2 of a sphere to fill up the cylinder with the same diameter and the same height. So what each of these gives us, though, is a relationship that we could actually use to find a formula for finding the volume of a sphere, which will be in the next video. But we could describe all of these sort of in equations also. So you could say the volume of a cone equals the 1/3 the volume of a cylinder. And you could also say volume of the cylinder is equal to the 3 times the volume of a cone. You could also say the volume of a sphere is equal to 2 cone volumes. Or you could say the volume of a cone is 1/2 the volume of sphere. And then you could also say that the volume of a sphere is equal to 2/3 the volume of a cylinder. You could also say the volume of a cylinder is equal to 3/2, or 1.5 spheres with the same diameter. Again, all of these, the relationship relies on having the same height and the same diameter of each shape. So watch the next video, and we'll look at how we're going to use this to actually make an easier, somewhat easy to use formula, and go over an example of how we would use that to find a volume of a sphere.